Prime numbers were one of the things that interested me as a kid. Around when I was in 8th standard, I started exploring the grids. Recently, this thought of visualizing Eratosthenes came into my mind, so I started this visualization. So, sieve of Eratosthenes is a way to find out all the prime numbers below a given number. In this case, let us take 100 as that number. And to find out all the prime numbers, we need to divide all these numbers by the prime numbers which are below the square root of 100, which is 10. 2, 3, 5, 7 are the prime numbers below 10. We will also look at how we can use this recursively to find that. Let me explain the visualization a little. We have 100 numbers put into a grid of 10 columns now. Clicking on any one of these things will convert it into a grid of 2 columns, 3 columns, 5 columns, 7 columns, and so on. Let's click on 2 now. So once you click on 2, it converts it into a grid of 2, and when we click on draw line for 2, it will basically strike out all the numbers which are multiples of 2. So let's click on this. So now as you can see, it has highlighted all the multiples of 2 in gray, saying that these are composite numbers and hence it cannot be prime. At the same time, since they are multiples of 2, you can see this line drawn in the color for 2. And we also have this option of show primes just for us to get a intuition as to where we are heading. So when you click on this, you can see all the prime numbers here, and some of these things are not primes because they would be divisible by any one of those things, and we can figure out what are those. Let's click on hide primes now and see if the pattern becomes emergent for us to observe. Now let's click on 3. It converts it into a grid of 3. Let's draw the line for 3 also. As you can see here, this is a multiple of 3 power 2, so there is only one line. 6 is product of 2 and 3, hence you can see both the lines for 2 and 3. If you want more details, you can click on this number and it will show you the prime factorization of that. And we can see a pattern emerging here that the probable prime numbers are in diagonals. Let us see how consistent that is. Now let's move to 5. So let's click on 5 now. Let's click on 5 and draw the line for 5. As you can see, it has drawn the line for 5. And as you can see, probable primes is becoming evident as diagonals in this. So now let's look at which are those which are not primes. As you can see here, there are some of them, 77, 91, etc. The probable reason could be the multiples of 7, but let's find that out. So click on 7 and draw the line for 7. Now as you can see here, these are all composite numbers which are in dark gray, and light gray or probable prime numbers or could be prime numbers because we are done with striking out the multiples for all the prime numbers below that. Let's just click on show primes now. As you can see here, it becomes pretty evident that these are the prime numbers. So now let's try to extend this a little more and try to see if we can do this for 200. So now that we know the process, let's try to be quick now. Multiples of 2, multiples of 3, multiples of 5. As you can see, the diagonals are becoming much more evident now. Let's do for 7. We can see the diagonals here. Similarly, let's do for 11. These are the diagonals. Looks like the direction of the diagonals are reversing with every prime. We're not very sure if that's true, but in further videos let's explore. But as you can see, sieve of Eratosthenes is a very good way to figure out what are the different prime numbers. And if you want to figure out the details of it, you can click on any of these numbers. For example, you can see that 104 is 2 power 3 into 13 here. Thank you.